Welcome back, Physical Science 20. This is part 2 of that 16.4 assignment. I left you with question number 4, doing problems 28 and 29. Hopefully you had a chance to do that. We'll go through them now and you'll be able to check to see how you made out. So if we look at this first one, just simply grabbing compounds here, seeing if you can find them in the following equations and seeing how you need to manipulate those equations to make it work. Once again, if we have oxygen, we usually just ignore it. This particular equation doesn't involve oxygen, so we don't need to worry about that. So 2CO is what we're looking for. So carbon monoxide, if you look in our equations here, we'll see it right here. Now we need it to be on the left-hand side of the arrow. It needs to be a reactant, and it is. We need 2 moles. We have 2 moles. So this first equation we'll just simply leave alone because I have one of the items that I need on the appropriate side, and I have enough of it. Okay? Secondly, let's look for, I could pick anything here, but let's look for NO. There it is right there, nitrogen monoxide. I need it to be on the left-hand side of the arrow. I need it to be a reactant, but it's not. It's on the product side, so I'm going to have to reverse the equation. I need 2 moles. I have 2 moles, so I have enough. So the only operation I need to do is simply reverse. Okay, so I will do those 2 things. So the first equation, just simply rewrite 2CO plus O2 yields 2CO2. And the enthalpy of that reaction is negative 566.0 kilojoules. Second equation, I need to reverse. It really helps if you line up the arrows first off before you write your compounds down, because you need to distinguish between left-hand side and right-hand side. So we have this, and we reverse the equation, so what was originally endothermic is going to become exothermic, because with endothermic reactions the heat is on the reactant side. If I reverse it, it's now going to be on the product side. Okay. Now we'll take a look at products that are formed that become reactants. Let's see here. What do we have? So we have 1 oxygen on the reactant side, 1 oxygen on the product side, so that'll cancel out. And I think, in fact, that's it. So I end up with 2CO plus 2NO yields 2CO2 plus N2. Now the sweet thing about this question is that, or these questions, is that you know if you've done them right if you get the same answer here. We're looking for this equation. We did get that equation, so that tells you that you did the question right. So all that's left over here is to figure out the enthalpy, combine those, and we get negative 746.6 kilojoules. So that's Hess's law once again. We look back to what we originally wrote here. Hopefully it makes more sense now. So if you can add 2 or more thermochemical equations to produce a final equation for a reaction, then the sum of the enthalpy changes for those individual reactions is the enthalpy change for the overall reaction. So that's in fact what we did there. Manipulating the equations to make them add up to give us the original equation, and then the enthalpies will give us the total enthalpy. Okay, I also left you with number 29. You likely weren't able to fit this on your paper, so you may have to do it on loose leaf. But here we go, we'll run through that. If I look here, looking for Al, there it is there. I need 4 of them, I have 4 of them. I need it to be on the left-hand side of the equation, and it is. So this one I will just leave. Okay, the next one, MnO2, there it is there. I need for it to be on the reactant side, it's on the product side, so I'm going to have to reverse. And also, I need to have 3 moles of it. I only have 1 mole of it, so I need to also multiply by 3. So reverse and multiply by 3 is the operation I'm going to have to do there. So just rewriting the first one, 4Al plus 3O2 yielding 2Al2O3, with the enthalpy being negative 3,352 kilojoules. And that second one, reverse and multiply by 3. So reverse MnO2 is going to be on the left-hand side, but I also need to multiply by 3, so I have 3. And the Mn now turns into 3Mn on the right, and 3O2 on the right. And the enthalpy was a negative 521. I need to reverse it, so it's going to be positive, and tripling it, 1563. So that's what happens with that one. And if I look at things that are substances that are formed that are then used up, 3O2 and 3O2, I can cancel those off, and I think that is actually it. So I result in 4Al plus 3MnO2, yielding 2Al2O3 plus 3Mn. And then the resulting enthalpy, negative 3,352 combined with the positive 1563, leaves me with negative 1789. So there you have it, those two questions that I left you with. I'll maybe go over one more with you, then I will leave you C, D, and E to go through. I'm not going to go over the answers, but I want you to actually try them, and when you hand them in, I will correct them to see how you made out. So I'll just go over B with you here. It's a relatively straightforward one as well. So here's the overall equation we want to make. So if we look, tin, Sn, there it is right there. We need one of them, we have one of them. It needs to be on the left. It is on the left, so we're good. We just leave it. If I look at chlorine, it's a little bizarre because both equations have chlorine in them, so you may want to skip that one. If we look at SnCl4, there it is. I need one, I have one. It needs to be on the right, it is on the right, so just leave it. Now, we wouldn't cancel these Cl2s, but we would combine them because they're on the same side. We can think of it, they're not being produced, then used up. They're just all on the reactant side. So what we do is we combine them all together. So what I end up with here is, wait a second, I can cancel something. SnCl2 and SnCl2. It's produced in one step, then used up in the next. So that's the only thing you can cancel out. So Sn plus, I have my two Cl2s, and that yields SnCl4. And if we look, yes, that's what I'm supposed to end up with. So again, Hess's law, if you can manipulate equations and add them up to get the result, then simply adding up the enthalpies will give you the resulting enthalpy. So there you have it. Negative 511 kilojoules is the answer there. So I'll leave you with C to do, and D, and E. E is a good one because it has three equations there that you can manipulate to result in the overall equation. So I'll leave you with those ones, and we'll see you in a bit. Bye-bye.